and essentially really what goes on in the workplace beyond just writing code. Yeah. A little bit about me before I start the talk proper. I'm Joyce. I actually started out as a technical product manager, in 2020. Then in 2022, I made like a mid-career switch to become a software engineer. Then 2 years later, I joined OGP as a senior software engineer in the Armory team. So for Armory is actually an app that digitizes checklists for agencies that previously conducted their checks on pen and paper. So we digitize that process. And our main stakeholder currently is actually SCDF. So SCDF uses Armory every day to conduct checks on, the fire vehicle trucks or the ambulances, right? So it's meant to help agencies be operational ready because they have to conduct checks on a day-to-day basis. So why do it on pen and paper, right? Yeah. Okay. The agenda is really simple today. I'll just be talking about like what do product engineers do, and then move on to why it's important, and lastly, how to work towards becoming a product engineer. So actually part 3 will be like the main bulk of this talk. Yeah, so what do product engineers do? I think very importantly, product engineers do not just code, right? And it's actually just very product-oriented software engineers. So product engineers build software with a focus on solving user problems and also still ensuring technical excellence because you're still a software engineer first and foremost. Yeah, and a very typical, I think most companies, they follow this life cycle of product development. You start with an idea, you conduct research, user research, data research, and then you go on to the design and development phase. After that's done, you deploy and roll out, and then you get user feedback, and the whole cycle repeats. I'm sure every firm have their own life cycle, but this is roughly the way OGP works. And a product engineer is actually involved in every single stage, not just in development. Yeah. Okay, and why is it important? Okay, the first part of why it's important is to avoid poor product quality. Because honestly, being a software engineer for about like 2 to 3 years, you'll be handed requirements that do not make sense. Your PM will pass you some requirements that you're like, okay. And if you simply execute these tasks, right, without like questioning why or thinking about the big picture, you actually contribute to the decay of your product because you're just like stacking on things that do not make sense. Yeah. So product engineers, I think really importantly, try to ensure what is built matters to the user in the long run. Yeah. And that contributes to the success of the product, right? Because you're trying to stack on the good stuff, the useful stuff. Yeah. And that is like your main outcome. And we're not that altruistic, right? So it's actually very important for career growth. So senior plus, I use senior plus to refer to senior staff lead levels, right? These senior plus engineers, they're actually expected to shape product direction, not just execute code. Like in the past few companies and also in OGP, is a very known thing where to kind of be more senior and be more senior career, you need to actually shape the product direction, help scope the product roadmap, think about how to improve the product, right? So on the right, I've pasted some example LinkedIn job postings for senior positions. Almost every posting had like a line of this sort where, you got to work with your team members to identify product requirements. You need to scope them and prioritize them and then ship incrementally to production. So it is very important for software engineers to start having a product-oriented mindset to grow in your career. Yeah. Okay. And moving on to like the main bulk of the presentation, which is how to be a product engineer. I prepared this quick guide. It's based on like my learnings all over the past few years in the tech space. So it's not like something that I pull out from internet, etc. It's like from my own learnings. And also there's very little resources online for product engineering, I realized while preparing for this talk. Yeah. Okay, so the first thing is I'll talk about how to achieve like a deep understanding of the product. Yeah. And second is focus on building and validating fast. That's a very important kind of trait of a product engineer. And the last part is to be pragmatic about using technology. Yeah. So for starting by understanding the product, right? What this means is you need to study how like the system works together and how they actually serve the user. This is important if you join maybe like a larger company for a larger product with a lot of microservices. Because normally when you join a company, you may only just be a part of a sub-function in a microservice. You're not even like going to work on a whole microservice. So what is important to really understand your sub-function very deeply, you need to understand how it fits in the whole system, like how it supports your downstream system, how you get data from your upstream system, and how it eventually funnels down to serve the user. Because for some background, previously I was in a company where I was on like a very back-end system, and it had to go through like 10 microservices just to see any user impact, right? Yeah. So sometimes you will join companies where you will be in that position. Yeah. And it's important to kind of understand this, because features do not break because of bad code. Like actually it's quite rare to break because of bad code, but it's most of the time it's because engineers do not see the bigger picture and they deploy something that just doesn't make sense. Yeah. So I just have a very simple example scenario that actually happened during like my first year as a software engineer, right? So an upstream API, let's say the situation is an upstream API is removing some response fields, like from an endpoint that you call from them. And your PM is like, okay, yeah, can you stop reading them, right? They just hand you like a Jira ticket and ask you to stop reading them. If you are like a good product engineer, you immediately recognize that, you have downstream systems that actually rely on these fields. So if you just remove it, like everything will break. Yeah. So a good product engineer response is you push back immediately. Always ask why, check, have everything checked, and then you push back. You flag the potential downstream impact. The next thing you do is you conduct like simple impact analysis. Maybe just blast like a message on your Slack, on like the engineering Slack channel, just letting people know, hey, there's this change that's about to happen. Yeah, is that going to affect you? And the third thing is you coordinate with them to ensure that everyone is prepared for the change. And then lastly, you do the typical things. You test for vulnerabilities, test the changes, right? So the outcome here is you prevent a system-wide failure just because you understand the system and you understand how your sub-function fits in the whole system. Yeah, and most importantly, you protect the users. Yeah, everything is always for the users. Okay, and the next part is building and validating fast, right? So for this, I'll just be going through some simple strategies that you should have under like your belt to ship small and iterate often. And the second thing is actually more important, which is how to learn quickly from data or from real users. Yeah. So some strategies to help in shipping quickly. This is what every product engineer needs to know, like these four main things. The first one is feature flagging, right? So feature flagging is really important, especially when you want to kind of just roll out the code first, but you need to do some preparation prior to the launch date, right? So you just literally like, the feature can be on or off. Yeah. So I use feature flagging quite a bit in my software engineering career. And the second thing is A/B testing. So for A/B testing, you essentially want to like roll out 2 versions of something, and then you want to see how that contributes to the performance of the product. So for example, let's say you're in a company where you're in, like there's a checkout flow, the normal shopping cart checkout flow, right? And you want to check whether maybe optimizing a certain UX flow will lead to an increase in conversions, right? So yeah, you will roll out that second version, that the change in the UX to like maybe a group of users. And then you compare and see how whether it really did increase the conversion rate at the checkout flow. I mean, if it didn't, then you got to roll back and redo it lah. But if it does, then that's good. Then that gives you confidence to roll out the full feature. Yeah. The third thing is block listing. Okay, block listing is more of like to help you like in manual requests. So for example, maybe you want to roll out a simple flow just to support your PM, for example. So you literally just block list your PM's user ID in the system. Yeah. And the last thing is canary deployments. So canary deployments is actually more useful for large-scale infrastructure changes or very complex backend changes. Actually, in OGP, we don't really use canary deployments, but in my previous e-commerce company, we use canary deployments quite a bit to make sure that we roll out to a certain percentage of traffic, and then we slowly incrementally increase as we monitor the application. Yeah. But the key goal of these strategies, right, is really to reduce the time wasted on guessing the impact of your rollouts or ensuring that everything is 100% like reliable or stable. I mean, obviously, you should try to mitigate the risk as soon as possible in your development or your testing QA processes. But sometimes you just gotta like roll out and like see how it affects that 10% of the users. Yeah. Yeah. Ship first, get information, and then iterate from there. Okay, and the second part which I wanted to mention was how to learn quickly from users or data and then iterate from there. Because after you deploy, right, you don't just, I think this is something that's really neglected, like for most software engineers. You just implement code and then you deploy and you kind of like forget about it. Maybe you just look at your metrics to see there's no abnormal number of error rates. That's it. But actually, application monitoring, and there's a lot more to application monitoring than that. Like you don't just track errors, you also track usage patterns. Whether there's a spike in like latency, whether there's a spike in suddenly this endpoint is being called like multiple times, right? So you need to spend some time in application monitoring so that you can learn from the data. Yeah. And the second part from learning from the data is actually internal dashboarding. So internal dashboarding is different. Application monitoring is your application health. Internal dashboarding is your product health. So you want to use internal dashboarding to visualize your feature adoption and as well as impact. Like for example, if like I mentioned, I worked in an e-commerce company before that. We had internal dashboard showing the entire funnel from product discovery to looking at the product and then adding to cart and then checking out, right? So we have a lot of these funnels and then checking the drop-off rates, etc. So for internal dashboarding, in my previous companies, thankfully my PM did it. But then I think in OGP, it's a very joint effort between your software engineer and the PM to make sure the internal dashboarding is very robust, so that you can quickly have a bird's eye view of like what your product health is and what ideas you can do to kind of improve some metrics. Yeah. And I think the last one is, if possible, stay engaged with the users. I say if possible because I'm aware that, sometimes you're just in like the super backend function that you cannot get to your users. But if possible, you stay engaged with the users. Try to get first-hand experience of how they're treating the product pre and post-launch. Yeah. So the good thing about this is when you talk to your users, you see how they use your product. You can just quickly like think of ideas and ID on the spot instead of waiting for your PM or your UX researchers to go down and like kind of get information, synthesize them, and summarize them for you. Yeah. So I'll talk a bit more about the third point because the third point is actually what we do a lot in open government products. Right. So as I mentioned, I'm in Armory team and our main stakeholder is SCDF, right? Where SCDF uses the Armory app to conduct checks on their ambulances, make sure the equipment is ready. Because previously they were doing this daily over like, I think thousands of equipment on pen and paper. So we digitize it for them. Yeah. So when I first joined and until now, like for every feature, we go down to the fire stations. We look at how they're using the app to conduct their checks. Because like what better way to know what your users are thinking than seeing them in action, right? So yeah, we do that quite a bit. Even after we ideate something, we will come up with a simple prototype and go to them and just ask them like roughly how do they feel about this before we actually decide to implement the feature. Yeah. And other than user testing sessions, like even post deployment, we conduct workshops for them. So the workshops are very important because okay, if you want to think about like moving the checklist on pen and paper to the app, right? Actually, it's quite simple. It's like just automating it. But we don't want to just automate their processes. We actually want to transform their processes. So these workshops are meant to facilitate how they use the Armory app. Like we actually have like pretty thorough workshops, just brainstorming with them how they can convert their checklist items. For example, like does this ambulance have items A, B, and C? We go through these workshops with them to see how we can transform the way they ask their officers questions. Yeah. So actually, you can see I'm in both of these photos. Yeah, I'm quite involved with the users, and actually Engineer OGP is very involved with the users because it's the most surest and fastest way to know like how to make your product more usable. Yeah. Okay, then the third part of my guide is to be really pragmatic about technology. Yeah, the first one is to automate processes as much as possible because like what I mentioned, product engineers, you do so many things. You have to go and talk to the users. You have to do internal dashboarding. You have to code, right? So you actually have to do a lot of things. And automating processes as much as possible actually is a key skill to free up your time. Free up the time for engineering. Free up your time to debate about metrics with your PM. Yeah. And the second thing is about finding opportunities for tech-driven improvements. Yeah, I'll explain more about this later. So some tips to automate your processes is actually meant for like speed and reliability. First thing is to spend time on developer tooling. like optimize the way you set up your environments locally so that you can code quickly and you can test your changes locally. Have like good pre-configured dev and UAT environments. The second thing is infrastructure tooling. So infrastructure tooling, okay, is a bit more complicated because if you have cloud provisioning, then you might like manually go and configure it. But actually, you can use this thing called infrastructure as code, like tools such as Terraform or Pulumi to help you manage your cloud provisioning much easily. So I will caveat that for the first two, normally in firms, you will have DevOps teams and SRE teams to help you with it. So if you do, then good for you. Then work with them, think of ways to kind of improve the efficiency of how you code and how your team codes. Yeah. But in open government products, we don't really have like a full-fledged DevOps and SRE team. So the product engineers actually do think about these quite often because we are always looking for ways to speed up our engineering time. Yeah. The third one is basic, integration and deployment. Rely a lot on your CI/CD pipelines to automate testing because, as I mentioned, we have very little, like we have to do a lot of things. Testing is going to be our best friend. Automated testing is going to be our best friend. You want to make sure that your CI/CD you have good test coverage and your CI/CD can catch any issues that come up. Yeah. And then the last one is to reduce manual process for engineers. This is a bit underrated because actually a lot of times especially when the product is a bit more mature, your PM or other people are going to ask you to do a lot of manual requests, like updating the DB data, or doing a lot of Jeng stuff, right? So actually, if you want to kind of automate that, it's quite simple. You just build simple self-serve endpoints like, for your PM to call. And also another thing is manual requests are pretty dangerous, right? Like if your PM just asks you to update your DB and then you just go and do it, but there's no proper validation, that's not very good for the system. So if you build some simple self-serve tools, it's also a way to track like what's being done to the state of your application. Yeah. Yeah, and also I have some tips for finding opportunities for tech-driven improvements. The first one, actually, optimizing performance is very easy. Like product engineers, as I mentioned, is still software engineers in the first and foremost. So actually, performance is pretty much at the center of it all. Because it can be as simple as you find some DB query that's not indexed, right? And then you just add the index, and you can see like how like much more quickly this user can access a certain feature, for example. Yeah, so it's important to exercise the muscle of like trying to think of ways to optimize performance, finding like random obscure DB queries that are super long and like just cutting them down, right? And the second one is studying new technologies. Yeah, so you have a lot of things to do, but you should still carve out time to study new technologies. For example, like AI, as I put in the example here, but we had a recent Hack for Public Good hackathon where the whole of open government products, we stop our product work for 1 month and we just think of like new products to build. And a lot of products were AI centered. Yeah, personally, I was in an AI team that wanted to train an AI bot to respond to scammers, for example. So if you learn all these new technologies, you will be surprised at how much you can do with it, especially AI. Yeah. Okay, so my main takeaway actually, and this is also my takeaway, is as I was preparing for this talk, is good software engineers are really just product engineers. There's no difference. Yeah, like all good software engineers should actually aim to be really product oriented. And I think I'll just take some time to debunk some myths that like I think that you guys have. Yeah. So the first myth is actually this myth is like the myth that I believed in when I first became a software engineer, which is like junior engineers, they do not have to be too product oriented at the start. They can just come in, wait for the ticket to come down and execute it and be done with it. Right. But so junior engineers, you should definitely still focus on perfecting your technical skills, like your code and testing quality. Learn as much as you can. Yeah, learn all the system design patterns. Yeah, but you should also still work towards a product-oriented mindset. Yeah, and you can just start by having a very deep understanding of the product that you're tasked with. Yeah, so that you can challenge assumptions and requirements. And also try to exercise the habit of finding small tech-driven improvements that land impact. Okay, the second myth is product engineering is unrealistic in mature product teams, right? So for large-scale mature products with like a lot of microservices, I think prototyping and shipping features quickly is definitely quite unrealistic. Like I think personally I've tried in like my previous companies, yeah, it's quite unrealistic. But there are still some product engineering traits that you can exemplify. So first, I think having a very deep understanding of the product, understand how your changes will affect everybody, not just like your function. Yeah. And the second one is to be pragmatic about technology. I've seen a lot of cases where software engineers suddenly want to migrate like their flows from an API based to event-driven architecture, like I don't know, build migrate their databases, for example, and build new features that that just don't make sense. So if you're pragmatic about it, right, you might just like automate existing developer bottlenecks, find that like as an improve that DB query. Yeah, you don't have to like think so big. Yeah, basically. Okay, yeah, and actually that's the end of my talk. Yeah, thank you so much for listening for the past 15 minutes. Yeah, thank you.
Does anyone have a question?
Oh yeah, sure. Okay. Okay, so his question, so what's your name? Oh, what's your name? JF. Okay. Yeah. So his question was like, what's the difference between deployment and rollout? So deployment is when you just deploy your code. But actually for rollout, there's a lot more processes that come with it. For example, after you deploy, you might have to configure certain configurations to make sure that you maybe roll out the feature in sequence. Yeah. So that's like the main difference. Yeah. So as I mentioned just now, some of the strategies to help in shipping quickly, like feature flagging, or that. Actually, that's part of the rollout process. Yeah. Yeah.
Hi, Joyce. I'm Yash.
Yeah.
Thanks for the presentation. I had a quick question about abstraction. So you mentioned how Armory's primary user is SCDF.
Yeah.
But say there's like another team that makes software for like hospital teams to also like checklist the equipment. So how much do you guys care about abstraction like this in a potential case where another team might also use tools that you have built? And at what point of the development process do you start caring about abstraction?
No, that's a very good question. I think Yash's question is about abstraction and it's related to the point I brought up just now about me being Armory and our main stakeholder being SCDF. You're absolutely right to say that we do think about abstraction. So actually, Armory, we are looking into the healthcare space at the moment. We are thinking of expanding to hospitals, and we also have other agencies like ICA trialing with us. So I think this comes with like working with your product manager. So I think the team decided to eventually abstract after like maybe 2 years of working with SCDF. And we kind of sized the SCDF market really. So I think we hit about maybe 70% of the checklist, and we're like, oh, actually maybe it's time to generalize our app so that we can serve other agencies, right? So it wasn't like a one-time decision. It was true, some agencies coming to us and saying, hey, we're interested in this. Then us like talking with them, engaging with them, and realizing, hey, actually our app can really help other agencies as well, not just SCDF. Yeah, so that's one like more of an anecdotal engaging users kind of process. But second is really through the data. The data was the one that told us that, hey, we have really covered most of SCDF. We have a very good working relationship with them. They're still interested in onboarding all of their checklists to Armory. Like basically 100%. So I think it's like time to maybe shift some of the team's resources to speak with other agencies.
I mean, if I can add a little bit on, since I was part of the original Armory team, it's a little bit like dealing with technical debt, right? So there will always be a question of like, what's the opportunity cost if you kind of like either ignore the abstraction or not pay off the technical debt. So in terms of technical debt, it would be a question of like how much longer it would take to actually deliver something. In the case of like not abstracting, it would be like what opportunities do we miss? It might be revenue opportunities, or in the case of government, it will be how much public good do we not deliver for the amount of money you're spending. So hopefully that helps.
Hi Joyce, I'm Mandy. I wanted to know whether there were times where after studying the requirements, you and your team realized that perhaps other off-the-shelf products might be more suitable, and how the team resolved this with the agency that you all work with.
Okay. So your question is basically like, how we decide whether to build it internally versus going out, is it? And so I think, okay, I'll speak a bit about why we decided to do Armory, because actually there are some checklist automation tools out there. There was this tool called Safety Culture, I think, where it's essentially just helping you create checklists and perform certain like audits, perform the checks and then audit those checks, right? I think we decided to go with Armory because of the customization it has to government. Yeah, and also it's missing key features. For example, like scheduling these checklists to various users. We saw that actually checking, right? Okay, as I mentioned just now, Armory is helping with operational readiness. Checking is not just like the first part of operational readiness. Operational readiness is also maybe auditing the issues that come out after these checks, right? So all these checklist automation tools, they didn't have all these features. And actually, after going through all these user testing sessions, we didn't come out with just Armory. We realized that SCDF also had a problem with inventory management. So we came out with another kind of sub-product called Pulse to help with Armory. Yeah. So I guess that's why we decided to just push on and develop our own tool, because we realized that operational readiness isn't just confined to checking. There's a lot more things to explore operational readiness. Yeah. Yeah. Okay. Sorry, I think I got to stop. Yeah, thank you so much.